Alright guys, this is going to be a quick review video about what we need to go over in our practical for our NMT 215 lab. Just so you know, this is a pretty rough cut of the video. I'm still missing a couple things and I'll point out what I'm missing, where I'm missing it. But I figured I'd get what I had out so you could study for your practicals next week. So first thing we're going to go over is our GM meter and the constancy of it. First, you're probably going to want to start out talking about the physical appearance of the GM meter. You've got your cesium 137 source there on the side under the garage door. You've got your volume on and off switches, your fast and slow detector speed switch, your battery test button, and your reset button. Right here you'll probably want to talk about the probe and how it's filled with inert gas that ionizes the radiation and turns it into a voltage, which the meter reads out. This is the switch that is your multiplier for the reading on the meter. So first you're going to want to get your background by hitting the battery test button to see that the batteries aren't dead and hitting reset. Switching the multiplier to 0.1 and waving the probe around to get any kind of background radiation. You're going to want to do this away from any radioactive sources. And you're going to multiply the reading on the middle millirentgen per hour meter by the dial multiplier. Now we're going to check the cesium source and turn the knob to the ×1 multiplier, open the garage door, and place the probe right up against the cesium source and reset the meter. And the reading on this is probably going to be about a 0.4 or 0.3. Now you put the probe back and close the garage door and twist the knob back to off. Now your constancy is done on your GM meter, and you're gonna record your background and your source check on the survey meter, which is also a GM meter, on your wipe and survey lab sheet in the binder. Next, we're going to move on to equipment quality control. As far as equipment goes, we're going to have our calibrators and our well counter. Now, in order to do any QC on this equipment, we're going to need our cesium sources to check to see if the equipment is still in working order. Now, the reason we use cesium to check our equipment is because it has a really long half-life of 30 years, so that we know the radioactivity in the source from when we got it is going to be pretty close to the same all the time. Now, to do well counter constancy, we use our bar cesium source and our 5-disc cesium sources. The bar source is just a plastic bar with a cesium isotope in the bottom. At any point now you can talk about the half-life and energies of cesium, talk about why we use it. These are the 5-disc sources and one cobalt source, but the cobalt source has a black mark on it, so you don't get it confused and use that to do your constancy on the well or probe. So what you're going to do is put the bar source into the well of the well counter, and then you're going to take your disc sources and place them around the bar source. You can stack them all at once, but I just like to put them in a circle around it so that you're not closing the lid right on top of the disc. Now, onto the software, you're going to go to calibration and click the drop-down menu and go to well, and then you're going to hit start and the computer will start doing its counts. Now, this will probably take within 1 to 2 minutes, but once it finishes its counts, it will send it to the computer and create a graph report like the one you see on the screen now. And then when we get the graph report, we will talk about the different peaks and valleys and what we're seeing on the graph. Now, more or less, this screen is just telling you that the equipment is working within acceptable ranges or not. It's explaining that the full width half max is within acceptable ranges and that the peak energy of the cesium checks out. So just explain that this screen tells you whether or not your equipment is in fact working or not. Now you're going to want to talk about the different radiations that we see in the graph. That's your barium peak to the far left. Right next to it is the lead peak. Then you've got your Compton backscattering all along here. You've got your Compton edge and your Compton valley. Next to that is your Compton plateau with your Compton peak right there and the technetium right next to it. Now you want to talk about your full width half max of your cesium peak. The full width half max is it goes halfway up the peak of your cesium source and takes that number divided by the difference between the two bottom numbers. Now after that, you're going to take the lid off your well, grab 2 of the discs from your cesium disc sources, and then we're going to use these 2 discs to do constancy on our probe. Now we take the 2 discs and we lightly place them into the bottom of the probe so that we don't break the discs, and then we go to the drop down menu on the calibration tab and go to probe, and then hit start just like we did for the well. Now our probe isn't working. So once it's done with its counts, it's just going to shoot up a report just like the well, except it won't let you accept it because it just doesn't work, even though it's within the peak ranges. The channel maps are weird, or the high voltage doesn't work. Shirley hasn't really told us about why it doesn't work, but just know that it doesn't work and hit cancel. And then once you're done with that, you'll go and print out your reports for your well and your probe. So click the print icon and then click print and then OK. And then it's going to start printing out the reports on the printer underneath the computer. It's going to print one for the well, one for the probe, and then once it's done printing, we're going to grab them and take them over and hole punch them so that we can put them into the binder and they won't fall out. Now, the binder that we're looking for is the Atom Lab 950 MCA binder. It's like the biggest one, hard to miss. And there are separate tabs for the probe and the well, so make sure you're putting the right report in the right tab. Now once we have both the reports in the binder, we're going to close it and put it back into the cabinet where we got the binder in the first place, where we put the rest of our binders for our equipment. Now we're going to do our constancy on our calibrators, and for that we use this liquid cesium source. It's in a separate little plastic vial as opposed to the bar, so you have to be careful when handling it because it might unscrew or spill or do something else, so always use your tongs when handling this source. Now what you're going to do is you're going to right here, you're going to do a background on the calibrator before you bring the source over. That's one of the things that I forgot to put in. And then you're going to take the source, put it in the plastic sleeve, and go over to your panel and take it from technetium and go to cesium. Now you're going to take this number and record it in your log under your calibrator notebook and go to today's date and record this number in the measured activity tab. And you're going to record it in millicuries as opposed to the microcuries that the display says, and as long as it's within plus or minus 5% of the actual activity the cesium source should be, your calibrator is working fine. Now you're going to take the source and use your tongs, put it back in its lead pig, and now you're done doing your constancy on your calibrator. And now that you're done with your constancy on both your calibrators and your well counter, you're going to take your sources and put them back in hot storage behind the lead-lined door so that you don't contaminate the rest of the room with radiation. And always make sure to turn your calibrators back to technetium. Please note that I forgot to do the background on the well counter, so don't forget to do that. Now let's move on to eluding your generator. Now, when you elute your generator, you're going to need a few things. You're going to need your gloves, you're going to need sanitary saline wipes, and tweezers. Now, you're going to need your eluate empty vial and your eluant saline vial. The eluant will have an expiration date on the label, as well as a volume at the top. Make sure you tell Shirley both the volume and the expiration date on your practical. And then in your eluate vial, all we have is some antipyrogens so that we don't kill the patients with an infected dose. And then you have your needle recapper, which you put on the eluate side of the generator. And you've got your lead pig, which we use to hold the eluate so that after elution from the generator, we don't have radiation just floating around. Now, this is your Mollytech generator. It's got a saline side and a collect vial side. The saline charge will have 2 needles and the collect vial will have 1 needle. Basically, the way it works is that the saline charge goes into the top of the generator and it creates a vacuum, and the saline will go down, pick up any technetium that's decayed off the molybdenum, and then it be sucked into the eluate vial due to the vacuum. Now, you'll need to explain the chemistry of why only technetium is bound and sucked into the eluate vial. In the column of the generator is molybdenum bound to alumina, and since alumina is a +3 charge and molybdenum is a -2 charge, they bond very strongly due to their ionic bonds. Now, when molybdenum decays into technetium, technetium is a -1 instead of a -2. So since it's not as strongly attracted to the alumina, it won't take any bonds away from the molybdenum bound to the alumina. So what happens is when the sodium chloride saline gets washed down into the column, the +1 sodium ions bind to the -1 technetium ions, and since the technetium is now bound to the sodium, it then gets sucked up through the vacuum into the vial with the saline. And since alumina has a stronger positive charge, the molybdenum is more strongly attracted to it than it is the sodium, so it won't bind with the sodium. Now I'm going to show you the process of actually eluting the generator, but we're going to use fake eluate and eluent vials for this. So what we're going to do is first we're going to put on our gloves. You always want to wear gloves when working with radioactivity. Because of Alara, you want to practice time, distance, and shielding, and even though gloves are very minor shielding for your hands, it is much better to, if you accidentally spill radioactivity on your gloves, you can just get rid of the gloves. Now you're going to take your sanitary wipes and you're going to make a boat by ripping 3 of the 4 sides of the package and unfolding it, creating a nice little boat. You're going to take your eluate and eluant vials and pop the tops off of them. They just snap off, so they're really easy. And then what you're going to do is take your tweezers, grab your sanitary wipe, and sterilize the tops of these 2 vials. Now, this swab isn't radioactive because both of these are non-radioactive vials. But now we need to use that same wipe and decontaminate the pig. And so we're gonna wipe the inside of the cap, take the swab, and then wipe the top of the pig, as well as feed it through the hole and wipe the inside of the pig as well. So you need to unscrew the bottom and take your swab again and feed it through the top and clean the inside. Now the reason you do the pig last is because the pig might have been contaminated and be radioactive. So you don't want to swab the pig first, make your swab radioactive, and then go and start trying to clean the eluate and the eluent with a radioactive swab. Now we're going to take our eluate collection vial, put it inside the pig, and screw the bottom back on. And then we're going to take our pig and our saline charge and our needle recapper. And we're going to take the saline charge and put it straight down onto the saline charge top. You don't want to twist it because you'll break the needles, and that's a low score in Shirley Land. And so you just put the saline charge on, and then immediately take your pig and push it down on the collection vial side and push it straight down on the one needle as well. And then you just wait for the saline to drop down to the column, pick up the technetium, get into the pig. Then you take the pig off, immediately cap it, and then take your needle recapper and put it on the collection needle. And then we leave the saline on there because it's already sterile and there's no point taking it off. Now we need to dispose of our radioactive wipe, so we take our tweezers, pick the boat up with the swab, and put it in the hot trash. Now that we have our elution, we need to test it for alumina and moly breakthrough. And in order to do that, we're going to need to use our dose calibrator. Now, the reason we test for molybdenum breakthrough and alumina breakthrough is because aluminum is very toxic to the body, and molybdenum has an extremely high energy keV photon as well as being a beta emitter, so it can cause severe damage to our patients if we inject a dose with too much molybdenum in it. So in order to do the molybdenum test, we need to use our moly pig. Our moly pig has 6 millimeters thick of lead in order to shield out any 140 keV technetium photons, while not being thick enough to block any of the high energy molybdenum gamma rays. So first we're going to hit tech and do a background on our calibrator. Now this piece of paper is what we'll be recording all our values on. And the first thing we're going to put down is the time that we eluted the generator. Now, first thing we're going to do is we're going to take the top of the moly pig off, away from the calibrator that we're actually going to do the test on, because we don't want to accidentally excite the calibrator and get a false reading. So we're going to unscrew the pig that we eluted the generator with, and slide the eluate into the top of the moly pig, and then take our tongs, grab the top of the eluate, and drop it into the bottom of the moly pig, and then put the lid back on the moly pig. I'm saying moly pig an awful lot. Alright, then we're gonna take the moly pig, take it over to the calibrator we'll be doing our test on. Next, we're going to take the plastic sleeve out of the calibrator and slide our moly pig into the calibrator. And then we're going to come over and hit molybdenum, and it's going to count down for 30 seconds. And at the end of the countdown is when we'll get our reading. So once the countdown is finished, we take our reading and record it in our moly assay box. We'll get back to that later. And then hit technetium when we're done. Now we take the moly pig out, take it back over to the other calibrator, and put the eluate back into the original pig. And to do that, we just grab the eluate, put it in the moly pig, and then slide it back into the regular pig, just like we did last time. And then, of course, screw the bottom back on the pig. And always leave the cap off your moly pig so people don't assume that there's something in the pig itself in your lab. Now we take the regular pig and the eluate back over here so that we can start our alumina test. Now what we're going to do is we're going to unscrew the bottom of the pig and slide the eluate into the plastic sleeve. and take the reading from our technetium and put it in our activity box. Now we're going to take our tongs and grip them between our middle and thumb and grab it underhanded in the middle of the eluate and flip it into the pig, and then screw the bottom of the pig back on. Now, in order to get the concentration of your eluate, you need to take the activity in millicuries and divide it by the volume of the elution to get your concentration. Now, you're going to divide your moly assay by the amount of activity you had in technetium. And as long as you have less than 0.15 microcuries of molybdenum per millicurie of technetium, that means the amount of molybdenum in your elution is safe to inject with. Now we're moving on to the alumina test. In your alumina kit, you'll find strips, much like pH strips, and a small bottle of 10 micrograms of alumina per milliliter solution. Now, in order to do this test, you're going to need a sterile wipe. Make a boat with it. You're going to take one of the strips and put it on the boat so that you don't contaminate the chucks when you do this test. Then you're going to need a syringe with a syringe shield and a nerd or a needle recapper. Now you're going to take the bottle of alumina solution and put one drop on one side of the test strip. Now you don't need this bottle anymore, so it can go back in the case. Now you're going to take your needle and put the cap in the nerd, take the lid off your pig with your elution, and then slide the needle through the septum into the pig, and then draw up a very small amount of radioactivity. You only need a drop to do this test, so there's no point in pulling out a bunch. So now you're going to put one drop onto the other side of the strip, and then put your needle back into the cap and recap your pig. Now, when you look at the test strip, where you put the alumina solution is going to be pink. So if the drop of your elution you put on the other side of the strip is not as pink as that, it means that your elution has less than 10 micrograms per milliliter of alumina and is safe to inject. Now you simply take the needle out of the syringe shield and put it into the hot sharps container. But since it's not actually hot and this is fake, we won't do that. Also, right here, you'll want to transcribe all the numbers you had on your sheet to a label to put onto the pig. Now onto the final step of our practical, wipes and surveys. So to do wipes and surveys, you need to take the vials with the corresponding numbers to every place you used radioactivity in the lab that day. A convenient list of which vial numbers correspond to which place in the lab is located on your wipe and survey sheet in the binder. So what you do is you take the cotton swab out of the vial, lightly wet the tip of it, and swab a 100 square centimeter area, and then put the Q-tip back into the vial. Then you will take the vial over to the well counter and put the vial into the well. Now, I forgot to film the actual wipe part, but if you go to the wipe tab, you hit start and click the right number. It's pretty self-explanatory. Now we'll move on to surveys. We're going to take the survey meter and move it all the way down to the times 0.1 knob. Hit reset and test the battery, and take the probe and put it right up against anywhere where you've handled radioactivity. Take that reading and mark it in your survey and wipe log. Note that if the printer on the well counter is working, you don't need to record each individual wipe counts. You can simply just print it out and put it in the binder with the survey sheet. And alright, that's everything that's on the practical. I'm probably still missing a couple things, but as a whole, that's pretty much the bulk of the information you guys need to know. So hope this video helped in any way, shape, or form, and good luck on your practical, everyone.